I've been building a robot, and though I've posted some images on my Instagram, I haven't actually spoken much about it. My communication skills are pretty garbage, and pairing that with self-confidence that closely tracks the tangent function, you've got a recipe for one quiet boy. But I'm here now, and I'm talking, so I might as well fill you in. I guess the first question to answer, really, is why? Why am I building this robot? Robots are dope. Do people still say dope? Okay, yep, that's close enough for me. Robots are dope. But some robots are more doper than others. The exact factors which contribute to how dope a robot is can get complicated, but the easiest one that comes to mind is its locomotion. Legs are pretty dope from the get-go. There's a lot to look at, it's relatively complex and gives a wide range of environments that the robot can traverse. Wheels, on the other hand, they're inherently not as dope. They're quite simple. There's usually not a lot of visual tomfoolery going on, so wheeled robots tend to make up for this by being wicked fast, doing odd things, or smashing stuff, all of which increase the robot's dope factor. Flying robots have a high dope factor. However, now that all the local youths can get a hold of them with like 2 weeks of pocket money, their dopeness has fatigued some, and so usually need extra bolt-ons to keep them interesting for longer than 17.5 minutes. I've chosen to build a robot with legs, just because it seemed like the right balance between painfully difficult and horrendously expensive. I've also opted to build it with 6 legs. Anything less and things start getting tricky. Any more, and it just seems to get more expensive with little added benefit. With 6 legs, it means I can cheat a little bit too, because during the walk cycles I can always keep at least 3 points of contact with the ground, so I don't have to worry about balance all that much. So how far have I actually managed to get with this? It all started with the design of the modular link. And I know that word kind of sounds like a buzzword. I mean, it is. But try and see it like a reusable design. Less unique parts usually means your design is cheaper to build, so that was the aim. The modular link was designed to make it easy to stick motors together to make limbs. In theory, you could cascade them to make a big old robot tentacle, but I'm not quite that desperate yet. I tested the links out by building a simple robot arm. It went alright. It had a little grabby thing, and I controlled each motor individually with pots. It became immediately obvious that this control scheme is a dumb bitch approach, so I endeavoured to do better. Next, I built the first robot leg. This spawned designs for a hip joint, and a little tippy-tappy foot thing. The biggest technical leap made in this part of the project was the use of inverse kinematics to control the leg position. Inverse kinematics is a type of animation where you start with positioning the end of a limb and use some math to calculate angles needed to get it there. I would explain how I derived my IK model for my robot leg, but I'm shit at maths, so it'd end up a bit long-winded. Maybe I'll do a video about it if anyone is interested. Thanks to IK, now I just set an XYZ coordinate in the code and the foot goes there. Taking that a step further, I can take these coordinates and put them into a matrix, and then cycle through the columns like frames in an animation, sprinkle in a healthy amount of linear interpolation, and boom, you've got a walk cycle. We're talking Big Bamzooki vibes. The leg ended up looking pretty top, so the natural next step was to think about making the rest of them, thus highlighting my next big problem. Mo legs, mo motors. Mo motors, mo tur driver. That was awful. I'm going to stick with it. The final robot has at least 24 servo motors, all which need taken care of. Servos are controlled using a 50 Hz PWM signal, which I'm sourcing from a PCA 9685. This chip is basically a bunch of counters which you can set how long the outputs are on or off at a given frequency. So I set it to about 50, and then feed in the IK maths via a microcontroller. Coolio. Except I didn't want this robot to be another Arduino Uno hot glued into a shoebox type deal. So I made my own PCBs from about as scratch as you can get before falling back into dumb bitch territory. Now this took quite a long time, and it hurt me physically, mentally, emotionally, and financially. But my mum likes to see the robot, so it's all worth it in the end. That was a quick rundown of what I've done so far. Once I've committed to the robot's final design, I'll probably go into more detail about certain parts, but for now, I'll just line up what's next. The motherboard. Consolidate the PWM PCBs and a radio control circuit into a single board solution. This should make manufacture simpler, cheaper, and slim down the robot a touch. Add-on modules. Look, I know I'm not as cool as I used to be when I was a teenager, and as a direct result, neither is anything that I make and or do. To combat this, I've put in a header in the motherboard design spec for add-on modules to bring the dope factor back up when this little guy has lost some of its luster. Oh, and not to forget a redesign of the body to accommodate the changes being made and make it a bit prettier and less like a lin bin with legs. Well, there you go. A little bit of a quick one. I haven't written anything for this part, so hopefully I'll just kind of get used to closing these out. If you've made it this far, thank you very much. You've made it further than about 89% of my family and friends will tolerate. But, you know, if I have to deal with these thoughts coming into my head, I'm going to put them somewhere.